station points. This is going to seem a little weird, but I want to do this with it, and I think you'll understand.
What is it, HML and VML?
Horizontal and vertical measuring lines. Okay, so you guys, if you take a look at this vanishing point and this vanishing point, or imagine this is a vanishing point here, and you've got one here, and then imagine this was a line of vision, and the way we normally find a station point with the right angle, you go like this, you put a right angle on this line, the horizontal measuring line, and you find the location where both legs of the angle go through those 2 points. And this, weirdly enough, is the station point. Now you might notice that I put station point 1, which seems odd, because there's actually 3 of them. And the 3 station points you can find by taking this distance and then swinging it to hit these other 2 lines. And these become station point 2, station point 3. Don't worry about it too much. It's a little bit of a geometrical weirdness, but it works. The thing is all of them are the same distance from the center of vision, so they're almost redundant, except they aren't, because you need them to find the measuring points for J. All right, so how do you find the measuring points? The same way we did before. You go from the vanishing point to the station point. You swing it up to the eye level. So that becomes measuring point 2. Vanishing point to station point. Swing it up to the eye level. That becomes measuring point 3. Now here's the weird one. Vanishing point to station point. Where the hell do I go with it? To the outside of the triangle again. That is the measuring point you're going to use for all of your verticals to see how much they foreshorten. Now, how do you find the cone of vision for this wonderful thing? The same way we did before. You take a 30-degree angle, you put it at the station point, except now you just draw it to the line of vision, and it's coincidental that it hit there, by the way. Now you guys may notice, man, that's a really small cone of vision for all that work. Yeah. So if you want to do a drawing like this, you basically do a drawing like this, work out a grid, work out the essential objects that you need, and then blow it up and sketch over the top of it. That's how I use it professionally when I've done this. Now, so you've got all that kind of in place. Now, how do you actually draw anything with it? You would go like this. I have to put my measurements along the horizontal measuring line or along the vertical measuring line here. All right? Now, I'm going to transfer them the same way as always. So like here, I need to transfer these to this line, to these lines. So I'm going to go from here, using measuring point 3, transfer it to there, transfer it to there, transfer it to there. You see what I mean? Same kind of thing we did before. Do the reverse on this side. VPs. And I'm basically drawing a Rubik's Cube. Sans color. Okay, you see the top of it? Now for the verticals, I have to transfer those as well. I can start off though by saying, well, these are the outsides. Do you see the convergence of those vertical lines across the face of each side? Now I'm going to cut them off in a second. So you can start to see it. Now, how do I cut off the verticals? This is one part that people sometimes get confused about. So these are my vertical divisions, and I need to map them onto this line here. So I go like this. Mark it there. Mark it there. Mark it there. And now when I finish it, to the VPs. Voila. Okay, now I want to show you one other thing that's kind of cool about this. Jay, how big's my cube?
It's 7 feet.
7 feet, okay. So the cube equals 7 feet.
Just
How
'cause,
far away are we from it?
20 feet.
No, we're not.
Oh, I thought you were just picking
I know,
random.
I know, I tease it. But it is big, so we're 7 feet away. So this equals 7, right? So how far away are we? That's 14. That's 7. So I guess we're about 16 feet away.
That was close.
Okay? All right. You just measure from the center of vision to the station point. Now here's a question. How tall is my viewer? Want to take a guess?
5? No, never mind. I don't know. I don't
Yeah,
want to
we're looking down on them. Think about it. Take
Yeah.
a guess. We're looking down on a 7-foot cube by that much. What would you guess the height is of our viewer looking down?
30.
Okay, about 16 feet. It's going to be close. I'm going to guess a little higher than that, maybe like 20 something. But here's how you figure it out. This is the ground. So that means that equals 0 feet. I want to find out what that is, where it crosses the eye level. So I take 7, $14, $21, that's 28 feet, and that's 21 feet. So I'm going to guess we have a 27-foot eye level. Yeah.
So, with two-point perspective, you mentioned a trick that, how